For this question, consider that the curve of fx is a quadratic 9 minus x squared, and gx also a quadratic, which is x squared minus 9. First, we need to find the area bounded by these two curves. Then we need to find the volume of the solid revolution when the region bounded by fx and the x-axis revolve about x-axis. So first we need to draw out the graph to identify the region bounded. For this will be the quadratic that concave downward. See, this is a negative x squared. So to solve here, we have positive, negative 3 as a roots for this quadratic. So symmetrical axis will be 4 on y-axis. So as you rearrange, you can see this is x squared plus 9. So when you don't have bx term, this is ax squared. When you don't have bx term, means your quadratic will be symmetrical at y-axis. So when you see here, x equals to 0, y will be equals to 9. So intersection for y-axis is 9. Then another graph where gx is a positive quadratic with concave outward. So when you solve this quadratic, also finding x equals to 3 and x equals to negative 3. So they're having the same intersection point as the roots. So quadratic. So this is gx, where x squared minus 9. Previously, the graph here is fx for 9 minus x squared. Therefore, the region bounded by these two curves will be this region. Then when we want to find the area, we need to identify this area is finding dx or dy, means we want to find this area by using vertically concept or horizontally concept. So obviously this area should be using vertically concept. So area, vertically concept means we need to integrate from a to b for the function where dx, so vertically. So two curve concept will be the curve up here minus the curve down here. So intersection point very obvious, it is negative 3 and 3. Therefore, for area formula, you will be integrate from negative 3 to 3. So two curve concept, the curve above, which is 9 minus x squared, minus the curve below it, which is x squared minus 9, and then integrate it with respect to x, means we're going to do this area vertically. So we can't do dy. As you can see, when you do horizontally dy, your curve is touch back your own curve itself. So this we only can do it by dx. To find this area, we're going to simplify, where negative become negative 2x squared, and then 9 minus become plus 18. Then integrate it, power plus 1 over new power, integrate constant, we become a x, upper limit which is 3, lower limit which is negative 3. So what is going to do for the next, we need to show upper limit which is 3 minus lower limit which is negative 3. Then only we simplify it by using calculator, you will getting 72 units square. Then for question number 2, we need to find the volume. So volume formula will be pi, integrate from lower limit to upper limit. Revolve about x-axis means you're going to do dx, so your function need to be in terms of x and square. So the region you need to bound it by fx and x-axis. So means that your region you're going to find here is this. So this is a region which is going to revolve about x-axis to become a solid. So this is the volume that we need to find, your x-axis and a function fx bounded by this part. So to find this volume, we need to integrate from the lower limit, which is negative 3, until 3. The function here, which is 9 minus x squared, to be squared, and then dx. So to integrate this, firstly we simplify our integration, where square we can expand. So it will be a squared, which is 81, 2ab minus 18x power of 2, and then plus b squared, which is x squared and square, will become x power 4. So after we simplify, then only we can undergo integration. Integrate constant, we get 81x. Integrate a x, power plus 1 over new power. So same with here, power plus 1 over new power. Upper limit 3, lower limit negative 3. So after we integrate, we need to show upper limit, which is 81 times 3. Upper limit minus lower limit. Then lastly, you can use your calculator to simplify. Here we get 1296 over 5 pi unit cube for volume.